over 9.8, the square root of 20, of 10, 40, 125, that's going to be 102.1. Now their two possible answers are two negative, 25 minus 102.1, and that's going to give us negative number, or we could do a negative 25 plus 102.1, and that's going to give us a positive value. Now, since times can't be negative, we are going to choose the positive answer, negative 25 plus 1. Is 77.1, and then let's divide that by 9.8. And so this is equal to 7.867, so that's how long it takes for the ball to hit the ground if it is drawn downward with this initial speed. So that D is the answer. Number 7, the velocity of rock in component from is V is equal to negative 12I plus 5J. What the speed of the rock and its direction with respect to the positive x-axis. So what you need to know in this problem is that the number that in front of the letter I represent the value of the x component, and the number of in front of that letter J represent the y component. Now, if you have Vx and Vy, you could find the magnitude of the velocity, which is equivalent to the speed using this equation. So V is going to be the square root of negative 12 squared plus 5 squared. Negative 12 squared is 144, and 5 squared, or 5 times 5 is 25. 144 plus 25 is 1969, and the square root of 169 is 30 meters per second. So that the value of the speed, which means we can eliminate answer choice A and B. Now, the next thing we need to do is calculate the direction of the angle. So we can graph it using the component. So let's draw a graph. So the x component had a value of negative 12. So we have to travel 12 units to the left. The y component is positive 5. So we have got to go up 5 units, and the hypotenuse of the right triangle that it formed is 13, which is the magnitude of the velocity. First, we need to calculate the reference angle, but our goal is to find the direction with respect to the positive x-axis. So this is the angle we need to find. So the angle is arc tangent, that is the reference angle, V divided by Vx. Now just make everything positive, and this will give you a positive reference angle between 0 and 90. So the y component is 5, and the x component is negative 12, but we are going to make it positive 12. So the reference angle, the angle inside the triangle, is 22.6 degrees. However, we need to find this angle. Now this measure is 180. That is basically the angle of the straight line. So we need to find this angle, which is 180 less 22.6. So if we take 190 minus 22.6, that angle is going to be 157.4. Now this quadrant to this quadrant 1, quadrant 2, quadrant 3, and quadrant 4. So now we have the direction. It is 157.4 with respect to the positive x-axis. So therefore, E is the right answer. Now, for which problem, whenever you need to find the angle is coordinate, when it is going to be equal to the reference angle, which you know how to find it using this formula. Just make sure everything is positive. If the triangle in the quadrant 2, like what we had in our example, is going to be 180 minus the reference angle, if it is in quadrant 3, then the angle relative to the positive x-axis is going to be 180 plus the reference angle, and quadrant 4, it is going to be 360 minus the reference angle. Cliff. Number 8, a pole rolls horizontally off of cliff at 23 meters per second. The range of the pole is 184 meters. How high the cliff? So here the picture that we have, we're going the initial speed of the pole 23 meters per second, and then it is going to follow this trajectory, and the range is 184 meters. So that how far it is travel in the x direction, how far does it travel in the y direction? So that distance is going to be the height of the cliff. Now, the first things we need to do is to find time of travel. How long does it take to go from point A to point B? So how can we figure that out? Well, we do have this equation in the range is equal to V x t. The range is basically the horizontal displacement. We know d is the equal to vt. Anytime an object is moving with constant speed, so we have the range, it is 148 meters, and we have the horizontal speed, which is 23. So now we can calculate the time. So it is 148 divided by 23. So it takes 8 seconds for the ball to travel from position A to position B. So now we can find the height of the cliff using this equation. D is equal to V initial t plus 1/2 at t squared, but in the y direction. Now V initial is basically 0, so the height is 1/2. At t squared, you can just simply use the equation to find the height of the cliff. Now dy is technically negative and is negative, but the two negative signs will cancel. So this is just going to be 1/2 times 9.8 multiplied by 8 squared, which is the time So the height of the cliff is 313.6 meter. So this is the answer of you plug in negative 9.8, you will get that dy is negative 330.6, but that simply means that the pole travels to 313.6 meter in the negative y direction. Thus, it is the height of the cliff is this number, so B is the right answer. Acceleration. Number 9, a truck slowly speed up from 15 kilometer per hour to 95 kilometer per hour in 2 minutes, which is the average acceleration of the truck in meter per second square acceleration. Square acceleration is the range in the velocity divided by the time it takes to go from Venus or the v final or the change in time. The final speed is 25 kilometer per hour. The initial speed is 15 kilometer per hour and the time is 2 minutes. So 95 minutes is 15 is 80 divided by 2 is 40. So the acceleration is 4 kilometers per hour per minute per minute. So now we need to take this value and convert it to meter per second square. There is thousands meter per 1 kilometer, so we can cancel the unit kilometers. So we have meter, which is good, but now we need to convert time into second square. So let's start with the minutes. 1 minute is equal to 60 seconds. So this unit is gone. Now the last things we need to do is convert hours into seconds. So 1 hour is 60 minutes. And finally, 1 minute is 60 seconds. So now we are left over which meter over second times second. Second times basically second square. So we have meter over second square. We have the right. Until that, we want now just go to do this math. So it is going to be 14 times 1,000 and then divided by 63 times. Or you could say divided by 60 to the hard power. So the acceleration is 0.185 meter per second square. So that the answer which correct, the answer choice A. Number 10, which of the following expression can be used to calculate the acceleration of the block on the inclined plane shown below? So what we need to do, draw free body diagrams. So here we have the normal force exerted by the inclined plane on the block, and here this is the force of gravity parallel to the inclined, so that just a component of the wave force. So this is the actual wave from force mg. Let's turn it into right triangle. So this angle is the same as the angle, same as the angle here. Now this side is adjust to the angle, so that is going to be hypotenuse times cosine theta, so that mg cosine theta and opposite to the theta, we have this side which is going to be mg sine theta based on sine is opposite defined by. So what this tells us is that formula force is equal to my cosine theta, mg cosine theta, and f g is parallel to mg sine theta. So those two are equivalent. Now let's define this at the y direction and this at the x directions. So the net force in this x direction is only equal this force there, no other forces in the x direction, and based on Newton's second law, if equal to ma, the net force is always the mass times the acceleration, and g is the mg since theta, sine theta. So now we can cancel the mass, so the acceleration does not depend on the mass in this problem. Rather, it depends on the angle theta, so the acceleration is g sine theta, which means that answer choice D is the right answer. Final speed. Number 11. Number 11 and 10, 8-kilometer box lies on 30-degree frictionless inclined plane as shown. Below, what is the final speed of the block as it slides down the inclined plane? Starting from rest for a distance of 200 meters. So based on the last problem, we know how to calculate the acceleration. It is g sine theta. It is dependent on the angle of the inclined plane. E is 9.8 and the angle is 30, so that it is 9.8 times sine 30. Sine of 30 degree is one half of 9.8 is 49, so the 40.9, so that the acceleration of the block down the incline, now it is going to travel distance of 200 meters down the incline. So our goal is to calculate the final speed. So we could use the equation V final square is equal to initial square plus 2AD. We have the acceleration. We have the displacement and the block start from the rest. So we know the initial speed is 0. So that is going to be 0 plus 2 times 4.9 times 200. So that equals the square of the final speed. So 2 times 4.9 times 200 stars 1960. Now the next things we need to do is to take the square root of both sides. So the final speed is 44.27 meter per second. So that the answer, which match answer is the number 12. Attention force of 500 Newton acts on 20 kilogram block. Pulling it to the right of constant kinetic friction force of 140 newtons act on the block. What is the acceleration of the block? So let's draw a picture. So let's say this is the block, and we are going to pull it to the right with the rope. So the retention force of 500 newtons that acts on block, and friction is causes motion. So when the block slides on the surface to the right, there is going to be constant kinetic friction force, which I am going to call Fk, and that's going to be 140 newtons. So keeping my friction always posts motion. So if the block is sliding to the right, the kinetic friction force is directed to the left. If the block is sliding to the left, kinetic friction will point to the right. So how can we calculate the acceleration of the block? First, we need to write an expression for the net force acting in the x direction. Now there is two forces. We have an applied force F, or we call it, because technically it is tension force, and that force is positive because it is pointing in a positive direction. And then Fk, which is negative because it is pointed in the negative x direction. So the net force in the x direction is going to be the tension force, which is 500 newtons, minus kinetic friction, which is 140 newton. So therefore, the net force is 360 newtons. Now, base Newton's second law, the net force is mass times relation, and the mass is 20. So the acceleration is going to be 360 divided by 20. So we can cancel a zero. So it is really 36 divided by 2, which is 18 meter per second square. So as we could see, answer choice B is the right answer. Net force. Number 13, which of the following statement is true concerning an object moving in a straight line in the positive direction with the constant speed? So if the speed is constant and if the object is not changing direction, then the acceleration in the direction is zero, and based on your second law, the net force is equal to mass times acceleration. So if the acceleration is zero, then the net forces has to be zero. So anytime you have an object moving in straight line, which with the constant speed, the acceleration is going to be zero, and the net force is zero. So A and C are true statements. B is the false statement, and D is the false. An object has mass, and as a result, it has weight force, which is mg, and that the weight force is balanced by the normal force on the horizontal surface. The normal force is not zero on horizontal surface. It is equal to the weight force of the block if there is no other force acting on it. Now, friction does not have to be zero, the block, or the object could have an applied force of 200 newtons. and the kinetic friction force could be the same 200 newtons. And so the net force, which is the difference between these two, is going to be zero. The net force can be zero, which means the acceleration can still be zero even with the friction present. A good example of this: imagine you are driving your car and you are going at 45 miles an hour, and you are not accelerating, you are not speeding up, showing down, but you are maintaining that speed. Your fall is still on dial. You still have to apply a gas to the car to keep the moving at 45 meters per second or 45 miles per second per hour. The two are not the same. By the way, let's say if you are going 45 miles per hour, you still have a put gas to car. And the reason why you have to do this is because friction is trying to slow down the car, so it means you are moving a constant speed. The force that the engine applied to accelerate the cars, it is equal. The force basically to the total friction force acting on the car, which could be air resistance. UH drag force, just all of treatment force that slow down the car. And it really does not apply to the wheel of the car, by the way, and the friction between the cars and everything else, but the net friction force acting on the car, which just plans to apply force by the engine, and so the car will move at constant speed. So the point is this acceleration can still be zero, even though there is the friction force acting on it. So the friction force does not have to be zero. So B and D are force statement, and A and C are correct. So therefore, the best answer is E2. Two of the statements have true. So is the right answer number of 14.